This is section 1.4, writing equations and inequalities. First, we need to understand what these things are. An equation is a math sentence with an equal sign between two expressions. Remember before in the earlier sections, we were just dealing with expressions. 3 plus x divided by 8, 3x times 4. Those are expressions because there was no equal sign there. Once you have an equal sign with two expressions on either side, it becomes an equation. Now, an inequality is a math sentence, but instead of an equal sign, you're going to have a less than or equal to, a greater than or equal to, a less than or greater than between those two expressions. An open sentence is an equation or an inequality with an algebraic expression. So an open sentence always has a variable in it. You need to know all the following symbols and what they mean. Equals, less than, greater than, less than or equal to, or greater than or equal to. You can combine inequalities. If you have something like this, x is greater than 4 and x is less than 9, you should combine those two inequalities to write them like this. 4 is less than x, which is less than 9. And you can read it like this. X is greater than 4 and less than 9. All right? So those two you combine. That's called an AND inequality or an AND expression. Here are some examples. The first one says a difference of twice a number k and 8 is 12. Look carefully at the wording. Whenever you see is, it means equals. Difference is subtraction. And twice a number means you must multiply it by 2. So in this case, to write the expression or the math sentence, we're going to write 2k minus 8 equals 12. In number 2, the product of 6 and a number n is at least 12. At least 24 means it's 24 or greater. It could be more than 24. Okay? So at least always means greater than or equals to. So in this case, the product of 6 and a number, product is multiplication. So this becomes 6n. And because it says is at least, that's greater than or equal to the number that's given, 24. In number 3, a number y is no less than 5 and no more than 13. That's a compound inequality. It has two parts, the part with the 5 and the part with the 13. It can be equal to both those numbers. Okay? So when we put this together, we have y is greater than or equal to 5 and y is less than or equal to 13 because it's no more than 13. 13 is the highest number it can be. Finding solutions are when you substitute numbers for the variable in these open sentences. Okay? And when you do, you can find that they're either true or they're false. If it's true, then the number is indeed a solution to the open sentence. So we're going to look at some open sentences below, and we're going to check to see if 3 is a solution. So we're going to substitute 3 for the variable. In number 1, 8 minus 2x equals 2. We're going to substitute 3 for the x. So this sentence becomes 8 minus 6. Does that equal 2? Yes, it does. So 3 is the solution here. In number 2, 4x minus 5 equals 6. Again, you substitute 3 for x. So you get 12 minus 5. Does that equal 6? No, it does not. So 3 is not a solution to the problem. Try the next two on your own and see if you can figure them out. You can pause this video if you need some more time. In number 3, 2z plus 5 is greater than 12. If you substitute 3 for z, you get 6 plus 5. 6 plus 5 is 11. Is that greater than 12? No, it is not. So 3 is not a solution. And in number 4, 5 plus 3n is less than or equal to 20. 3 times 3 would be 9. So on the left-hand side, we have 14. Is that less than or equal to 20? Yes, it is. So 3 is the solution. You can do lots of these problems with mental math. Be careful, though. It's easy to make mistakes and misinterpret signs. So if you need to, write those steps down. Remember, on your quizzes and tests, you'll be getting credit for all the work that you do correctly. So if you write those steps down, even if your end result is incorrect, you'll be getting partial credit. So keep that in mind as you're doing your homework. You might want to get used to doing that. You should be able to solve the following problems for the value of the variable in your head. So now instead of substituting a number for the variable, we're going to solve for the variable. X plus 4 equals 10. Well, to solve this, you want to isolate the variable. Get the variable all by itself on the left-hand side. So in the first one, subtract 4 from both sides, and you get x equals 6. In 20 minus y equals 8, we're going to subtract 20 from both sides, right? And then when you do that, you get negative 12 on the right-hand side. If the opposite of y is negative 12, then y must equal 12. You can think of it that way, or if you'd like, you may multiply both sides by negative 1 to actually solve for y. 6n equals 42. Divide both sides by 6 to get n equals 7. And then the last one, a divided by 5 equals 9. We're going to multiply both sides by 5 so that we have a all by itself on the left-hand side, and then we'll get a equals 45. In example 1 here, this word problem about mountain biking, it says you paid $17 for 4 tickets to go mountain biking, and because of that, you get $10 off the list price. What's the regular price of a ticket? Okay, so first we're going to identify and define your variable. Always do that first. What are you trying to solve for, and assign a letter to that. So we're going to set P equal to the regular price of a ticket. In step 2, you're going to set up your equation. So if P is the regular price of a ticket, then 4P is the cost that you're going to pay for 4 tickets, but they gave you a $10 discount. If you subtract 10 from that regular price, you're going to end up with the 17 that you actually were charged. Okay? Once you have that equation, you can solve for P to get the price of a regular ticket. Okay? So to solve for P, I'm going to add 10 to both sides. So I get 4P equals 27. And then I divide by 4 to get P equals $6.75. There are lots of different ways to solve this depending on how you think about it and how you define your variable at the beginning. Some students like to set, rather than P for the price of an individual ticket, they'll set their variable as the cost of 4 tickets. So they would be solving for the total regular cost of 4 tickets, and then they would divide by 4. It's just how you want to set it up. That's why you want to make sure you define that at the beginning. In example 2 about basketball, a basketball player scored 351 points last year. If the player plays 18 games this year, will an average of 20 points per game be enough to beat last year's total? Again, the first step is to set up and identify your variable. We're going to define it. We're going to let P equal the number of points per game. So we're going to write a model to calculate the number of points per game necessary to break the 351 total that he had a year ago. You know that they're playing 18 games. So we want 18P, when P is the points per game, to be greater than 51. The wording in the problem is very important here. It says enough to beat last year's total. That means the total has to be greater than last year's total. It didn't say equal to or greater than. It just said beat the total. In step 3, we're going to evaluate it to see when P is 20 if the total is in fact greater than 351, because we're assuming that's what this athlete is going to average per game, 20 points. So we take 18 times 20 and we get 360. 360 is greater than 351. So an average of 20 points per game is enough to break the record.